All right, y'all. Today we're going to do another day of completing the square. It's really kind of a fun way to just be able to manipulate the function further to do what we want to do with it. Just get your mind right before we get started. We're going to be using some fractions today, but that's no big deal. This is going to be way easier, especially with fractions, than if we had to use the quadratic formula, which is going to be coming up next. So focus on that. This is the easier way to do it if there are fractions. So please, in a moment here, after directions, pause this video. You're going to solve each one of these mentally. These skills that you're going to use right now to do this is really going to help you with today's lesson. So make sure you give it a good shot. Just jot down what the answers are to get the answers mentally. Please pause the video. And when you resume, we'll have some answers. All right, x plus x. Saying what plus itself is 1/4? I'm looking at 1/8. 1/8 plus 1/8 is 2/8. 2/8 is 1/4. Okay. If I square 3 halves, I get 9/4. 3 times 3, 9, or 2 times 2. 3 times 3, 2 times 2. This is kind of what it'd look like if you'd expanded it. All right, what would I have to add to 3/5 to get to 9/5? The answer is 6/5. And lastly, this is the one that if you had a little trouble, what I suggest is thinking of 1/4 as 3/12, and then you can see that this would have to be 2/12 or 1/6. Either way is good there. All right, you need that common denominator to add or subtract. Feel free to pause here if anybody needs it. All right, so I'm going to ask that again. You give time for students to work by clicking pause, reveal an answer, then we'll do pause again. I'll give you those prompts. So we're going to just solve all these by what we did yesterday, completing the square. So starting with number 1, I'm going to choose to get that out of the parentheses, x squared minus 2x minus 3 equals 5. And so again, I just distributed there. Add to get b, multiply to get c, as we've seen a million times. And so I'm looking right here. We want a perfect square situation to happen here in order to complete the square. And I see that I get that -2 with a -1 and a -1. So I need this number to become 1 because -1 times -1 is 1. So I'm going to add 4 to both sides. And I'm going to look like this. And the reason we did that is now -1 plus -1, -1 times -1, I can factor to x minus 1 squared equals 9. Now we have completed that square. We have a perfect square. And the reason we want this is x minus 1 can equal 3, and x minus 1 can equal -3. Which gets us our 2 answers for a quadratic. 4 and -2. Feel free to rewind that, watch it over again if anybody wants to jot it down. Pause here, please. As well, whatever the kids need. And then give a pause. I'll work on the second one in a moment. Okay, so for the second one, I'm going to rewrite it just in my workspace up here, as you might be doing in your, fresh in your notes. So I'm seeing this 1/2, and I'm thinking what times itself is 1/2, or what plus itself? And the answer is 1/4, okay? So I know for that, to complete the square, that was a 1/4 plus 1/4. So for my C term, I want a 1/4 times 1/4, which means I'm adding 1/16 to both sides. That's why that warm-up was so important. So if I add 1/16 to both sides, I look like this now. This is 4/16, which is 1/4. That's why I wrote 1/4. Okay. Oh, I said 16th and wrote 6. There we go. So now I'm going to factor it because I completed the square. I've got a 1/4 times 1/4 to get me my 1/16. I've got a 1/4 plus 1/4 to get me my 1/2. And I am left with 1/4 on the right side. And this is good because then I can set up my two answers. X plus 1/4 can equal 1/2. Remember the square root of this thing. The square root of 1/4 is 1/2. And x plus 1/4 can equal negative 1/2. Which leads us to our two answers. So a lot of times right here, what's easier to think of is instead of 1/2, thinking of it as 2/4. 2/4 minus a fourth is 1/4. I find that easier to think about. Here I'm going to subtract a fourth. Again, I like to think of this as negative 2/4 instead. Negative 2/4 minus a fourth, negative 3/4. So there's more fraction stuff going on, but it's all the same big idea still. Feel free to rewind if we need to, and then we'll pause, give students a chance to complete problem number 3 before checking out what I did. All right, we're checking out problem number 3 now. Okay, so we're going to rewrite it in our workspace. And I'm looking at this now and wondering if I might do a little different than when I did it before. I'm noticing that 8/4 is a 2, but I'm actually going to keep it like as a 2. So looking at this middle term, it has to add to be that. I know it needs to be the same. So half of 3 is 1.5. I think it's going to be easier for us to work with 3 halves, okay? So I want this right here to be 3 halves times 3 halves. If it adds to be B, I want to multiply to be C. And you might even recognize this from your warm-up. I need C to be 9/4. So I'm going to keep that as 8/4. Because to get 8/4 to be 9/4, I'm going to add a fourth. So then I have x squared plus 3x plus 9/4 equals 1/4. Again, the reason we want that 9/4 is I can factor and get this. 3 halves plus 3 halves is 3. All right, 1.5 plus 1/2 is 3. And 3 halves times 3 halves is 9/4. So this works. And the reason I want this to work is I can set this equal to the square root of 1/4, which is 1/2, or this negative 1/2. Right there. Those are the two answers for the square root of 1/4. I'm going to subtract 3 halves from both sides. So x is negative 1 right there. Negative 2 over 2 is negative 1. And this is negative 2. Negative 4 halves is negative 2. So there are my two answers completing the square. Remember, adds to be B has to multiply to be C. So I needed to manipulate my C term to be 9/4. So that fraction 8/4 is actually nicer than using whole number 2 there. All right. Please pause, look it over, and then we'll start it back up when students have finished problem number 4. All right, so for number 4, I need to get that out of the parentheses first. I've got a 21 minus 10x plus x squared plus 3 equals 0. And I'm going to rewrite this. I just like my x squared term first. I'm just rewriting this, and I'm going to combine my like terms here. 24 equals 0. So my b term is 10, which is a negative 5 and negative 5. I need negative 5 and negative 5 to multiply to be c. So if c needs to be 25, I need to add 1 to both sides. Right, again, I got that because the 10 is negative 5 plus negative 5 if it's the same. So I'm going to rewrite. Now I can factor. X minus 5 squared equals 1. And that's important. Negative 5 plus negative 5, negative 5 times negative 5. Check. So the square root of 1 is nice to work with. It's 1. So x minus 5 can equal 1 or negative 1, which gives me my two answers. X is 6 and 4. All right. So take a moment, pause it to rewrite it, and then give a nice pause leading into number 5 so students have a chance to work on it on their own. Okay, so number 5. I'm going to rewrite. I guess you're rewriting it. I can rewrite it too. And I'm seeing 0.8 plus 0.8 there. So I need a 0.8 times 0.8 for the third term, which means I need another hundredth here. I need to add a hundredth to both sides to get that to be 0.64. So even though it's a decimal, it's no big deal. It's the same as what we've been doing. That's great. It adds to 0.8, adds to be 1.6, multiplies to be 0.64. And you could check the square root of 0.01 in your calculator, but it is 0.1. 0.1 times 0.1 is 0.01. So 1/10 and negative 1/10. I'm going to isolate my variables. Negative 0.7 and negative 0.9. There's the two answers. And again, we're going to learn the quadratic formula next class, actually, that we have math. And these decimals and fractions will work less nice in there than it does here. So just get away from worrying about if it's a fraction or decimal. Go to concept, same concept. Take a moment, pause if you need to, rewrite it. All right, so next, you're going to work through these four things, all right? Then, when you are done, so after a pause, you will look at these solutions. And those solutions, I'm not going to let you look at it too long. There's an error in each one of those solutions, okay? So what this is going to take is some time for you to look here. I'm going to insert a slide just with the answers and all the steps, which you can check your work against. And then I'll have you're going to look at that, and then you're going to find their mistakes, all right? So please pause, give some good work time for all four of these. When we resume, I'll have a sheet, or I'll have a slide up with just all the answers. So it won't be worked out problem by problem. They'll just all four will be there. So please pause. All right, so here's the reveal of the four problems listed. Feel free to take a moment, compare answers, write down anything you need to. You can see kind of in my steps, you can see where I added what I needed to add to get B, multiply to get C. You can see where I rewrote my equation. You can see where I wrote factored form, and then where I listed my two different answers by taking the square root of the 25 there. They're all set up the same way. So again, what you're going to do next is you're going to look at the next slide after you pause and make sure everything's good here, and you're going to look for the error in the work on those slides for these same problems. So please pause. All right, so here's the slide that you need. You're going to look for the error in this work. So look step by step. Look for where they screwed up. Compare it to what your work is. So this should only take, I'm thinking, like 5 minutes. So please give it a nice pause. Gauge where students are at with it. Find the errors, please. All right, we're going to go looking at these errors together then. So for problem 1, I found that error right here. So if I've got that 14x, that comes from 7 plus 7. I need that number to be a 49. So right there, should be 49. We need that perfect square. When we factor, 7 times 7 doesn't give me 28. So everything's going to be wrong after that. Problem number 2. Find the answer issue right here. We need to take the square root of that number. So these two numbers down here shouldn't be 9 and negative 9. They should be 3 and negative 3. For problem 3, when they took the square root of 64, they only gave one answer. We would need that second answer. So we only got one of the two answers. We need that negative 0.8 as well. And on number 4, they added a different amount to both sides right here. So if they went from 1/5 to 9/25, okay, so one way to think about 1/5 is 5/25. How do we get to 9/25? They had to add 4/25 to both sides, which would mean that shouldn't be 9/25. That should be 4/25 if they did it like that, okay? So that's the mistake there. If you add it to one side, you have to add it to the other. Both sides aren't going to be the same. And 4/25 is still nice to have over there because when we square root that for our two answers, we'd get 2/5 and negative 2/5. That still works nice. Okay, so that's it. If you add it to one side, you add it to the other. We added 4/25 to both sides, not 9/25. All right, there it is. Cool down with our lesson summary. Okay, complete the square. Let's just do this together. So I'm looking at that 5x, and I know that I need 2.5 plus 2.5, or 2.5, which is, I think, just so you know, I like dividing it by 2, right? That's 5 halves. That is 2.5. So I like to work with that 5 halves, actually, because that means if it's 5 halves plus 5 halves to be right here, I need 5 halves times 5 halves to be right there, which is 25/4. I'm going to get that to be 25/4 by doing what? So I know that I want that to become, if I square this, right, 25/4, which means I need to add 100/4 to both sides. Then I'm left with x squared plus 5x plus 25/4, which is what I wanted, equals 100/4. So now we can, since we completed the square, we can factor this. X plus 5 halves squared equals 100/4, right? Adds to be 5x, multiplies to be that 25/4 now. And this 100/4 is nice because this means that x plus 5 halves can equal 10 halves, right? The square root of 100/4. Square root of 100/4 is 10 halves. Or x plus 5 halves can equal negative 10 halves. So I'm going to subtract 5 halves from both sides. Subtract 5 halves from both sides. And we get two answers. We get 5 halves. 10 halves minus 5 halves. And we get negative 15 halves. So this parabola must cross twice, right? Cool. All about completing the square, adding to get B, multiplying to get C, and making that equation work for us. Get after that homework, y'all.